All right, good morning, everyone. Here we are. We're skipping 7.3 now today, and we're going on to section 7.4. Like 2 more sections to go for the semester. That's pretty good news. All right, so in section 7.4, we're going to be talking about equations that are quadratic in form. And well, I'm going to introduce you to something that is called U substitution. That is kind of like a preview for your higher level math courses. Okay, it's good to understand substitution. So basically, here's what I'm going to be talking about. Take, for example, example 1. I've got to solve for x in this problem. And then I can see that I have a binomial squared. And then it's minus 2 to that same binomial, minus 8. So what I want you to do is I want you to practice doing this by saying that u is going to equal this middle term here of which would normally be a single variable like x. All right, but now it's x plus 3. So I want to rewrite this to say that u equals x plus 3. Okay, and then I'm going to substitute for every x plus 3 the u. Or I'm going to substitute u for every x plus 3. So when I rewrite this problem, it's going to be u squared minus 2u minus 8. That equals 0. And then I'm going to factor this in terms of u. All right, so our same methodology for doing this as I taught you is to, the lead coefficient is 1, so I'm just going to factor this like I know how. Minus and plus, and then what am I going to have here? A 4 here and a 2 here. All right, then I can finish this off by answering it in terms of u by saying, well, that u equals 4 and that u equals negative 2 to satisfy this equation. All right, that'll get me in terms of u to answer it, but we need it in terms of x. So I have to go back up here and substitute back in the x plus 3 for each of the u's. So I'm going to look at that and say, well, u equals x plus 3, and that equals 4. So after I subtract 3 from both sides, I've got x equals 1. And same with the other second answer. I've got that x plus 3 equals negative 2. That's what u equaled. So when I subtract 3 from both sides, I'm going to have that x equals negative 5. And these are the solutions I'm looking for in terms of x, not of u. If I go back and substitute, let's see what happens if there's a problem with that. Well, let's see what we say. 1 and negative 5 are my 2 answers. I got 1, negative 5. Let's figure this out. I got, if x is 1, then that would be 1 plus 3 is 4, and 4 squared is 16. Okay, there's a 16 here. And then here I've got, if x is 1, I've got 1 plus 3 is 4. 2 times 4 is, or negative 2 times 4 is negative 8. And then minus this 8 equals 0. So that checks. So 1 is a solution. Now I'm going to check the negative 5. All right, if we know that to be true already, I circled it. I'm going to get rid of this just for a little bit of work room. All right, we know that, use substitution, blah, blah, blah. All right, so I'm checking negative 5. So negative 5 plus 3 is negative 2. Negative 2 squared is 4. What's going on here? 4. And then I've got negative 5 here for this x is plus 3 is still negative 2, and negative 2 times negative 2 is positive 4 minus 8. So 4 plus 4 minus 8 equals 0. So that checks out too. So both of those were our solutions for that problem. Okay, and that's what we're talking about. Let's go on to the next one. Okay, here's the problem written in the book. They had it equal to 2, so I just got the equation to equal 0 as my startup. All right, and then look at what we got here. I got 4x to the 4th plus 7x squared minus 2. So this, remember that index number, or that the power problem here. What am I trying to say? Slow down. Let me slow down for a moment. That exponent tells me how many answers I'm going to have to the problem. And it's saying I could have up to 4 answers for this problem. All right, that being said, I'm not real comfortable using x to the 4th, so I'm going to substitute here. I'm going to say that u equals the middle term here, the variable of it, x to the 2nd power. Not 7x squared, just x squared. So u equals x squared. So for every x squared in the problem, I'm going to substitute a u for it. Okay, and look at, well, let's do this one here first, 7u. And well, I've got it written here. But now I'm coming to the 4th here. I got 4. Well, x to the 2nd power is u. So that means I've got to raise this to the 2nd power. And this is just a demo here to show you that this will work. So now I'm going to have, there's my x to the 2nd power. And u equals x squared. So this first term here is going to be 4u squared. Okay, so get your understanding of this down. I changed the x to the 4th to be x squared raised to the 2nd power, which is the same thing as x to the 4th. Now I can substitute the u for the x squared. And then I'm going to go on and write this as plus 7u minus 2. That equals 0. And there we go. So I've got this to do for my factorization. All right, I'm stuck with the 4, it looks like. I can't factor it out, so I'm going to do the grouping method. 4 times negative 2 is negative 8. I need 2 factors of negative 8. That'll add up to be positive 7. And that looks like it's going to be 8 times negative 1. All right, that gives me my negative 8. When I add it, I get a positive 7. So let's rewrite the problem to be 4u squared plus 8u minus u minus 2. Okay, and we know it equals 0. All right, we'll group them now. And the first binomial here, I'm going to factor out a 4u. And what's left is u plus 2. I'll bring down my minus sign. Between a u and a 2, I can take out the 1. I want to make sure I do that, of course. And then what's left over is u. Negative 2 divided by negative 1 is positive 2. And there we go. So then I'm going to factor out the common binomial factor of u plus 2. Cross them off and say what's left over? 4u minus 1. Okay, so we've got this in terms of u, but we need it in terms of x. So I got to substitute back, that's a 0 there, that u equaled, what did it equal? X squared. So I'm checking on that. You do enough problems, you get mixed up. So I've got u equals x squared. I'm going to replace the u with the x squared. But first I'm going to solve for u here. So I could say this one is u equals negative 2 to satisfy it in terms of u, and then replace the u here with x squared. This one will be x squared equals negative 2. Okay, and how about I continue this now? Take the square root of both sides. So x is going to equal plus or minus, let's see, I got -2, so that must mean it's going to be I comes out front, and then with the square root of 2. Nothing you can do with that. So those are two answers there. One's positive, one's negative. All right, then I'm going to do the same thing with the 4u minus 1. Let's get it in terms of u first. So that means what? I've got u is going to equal 1/4, right? I'll add 1 and then divide by 4. And then u equals x squared. Okay, I like that. And then take the square root of both sides. This one I like doing separately. And how about we have x equals plus or minus 1/2. Square root of 1 is 1, square root of 4 is 2, and these are our other two answers in terms of x. And this is it. I've got 4 answers here that will satisfy that equation. All right, very, very good, very nice. And let's go on to example 3. There's only 3 or 4 examples in this section, so that's good. Okay, this one takes a little more understanding of what's happening with this. So let's kind of look at this as you're kind of like going backwards, really, or the inverse of what we did up here. Let's see. So I'm going to look at this. I'm going to say that u equals the square root of x. All right. So that means x is going to be written as the, if I want the x to be the square root of something, it would have to be the square root of x, but I'd have to do what? Square it for it to go back and equal x. But I've got my first term being to the second power, which is kind of like my semi-goal here. All right, if that's true, then this would be written as, I'll write it the rest of the way, plus the square root of x minus 6. That equals 0. Now I can say, use my substitution, that u equals the square root of x. And this is my square root of x here. And when I square it, it equals back to the x. So this is good. This is a good setup here. All right, so now I'm going to substitute for the u into it, and it's going to be u squared plus u minus 6, that equals 0. And now we're on our way. All right, this is an easy factorization, this one. Well, it should be. Okay, and I got a u here and a u here, a plus here and a minus here, and it looks like my two numbers are 3 and 2. To do that proper factorization. All right, satisfying the equation in terms of u, I've got u equals -3. And this binomial, u minus 2, it would be u equals 2. Okay, so I got my answers in terms of u. Now I got to put back that u equals, make sure, the square root of x. So I've got the square root of x equals -3, and the square root of x equals 2 for the other side. And let's satisfy your answer in terms of x. So I'm going to square both sides, and I'm going to have that, what, x equals 9. And then on this side here, if I square both sides, I've got x equals 4. So we've got two answers, but with the square root, whenever I have square roots involved, I've got to check my answers. All right, so let's go back to the original of, this is the original equation. I'll substitute my answers for that. Okay, let me rewrite it down here. I've got x and what did I say? Plus the square root of x minus 6, that's equal to 0. So if I plug in 9 here, I'll have 9 plus the square root of 9 minus 6, that equals 0. And I don't think it's going to happen here. I got 9 plus the square root of 9 is 3. And that 9 plus 3 is 12, minus 6 equals 0. Well, that's false. That's false. So 9 is not an answer. Come back up here, and whoop, this is not true. So now I got to plug in for the 4. Or if I plug in 4, I'll just do it right here. Let's do it in red. So if x equals 4, it would be 4 plus the square root of 4 is 2 minus 6. And all this, 4 plus 2 minus 6, does indeed equal 0. So this is our only answer for that one. So that's another tidbit to remember, is when you're dealing with square roots, you have to go back and check your answers to make sure, because the square roots could be plus or minus. All right, let's see. That was example 3. In this application problem, I'm going to go through it with you, but they kind of got it. They're kind of twisting it around something that all this work is not necessary. All right, it's a good theory, I guess. Maybe I should, but I just wanted to put some common sense into this problem. All right, let's hold on. All right, here it is. If an object is tossed into the air with an upward velocity of 12 feet per second from the top of a building h feet high, little diagram here. So here's the building. Top of a building is h, the height, whatever that is. The time it takes for the object to hit the ground. All right, here's the ground. Hit the ground below is given by the formula 16t squared minus 12t minus h. 16t squared minus 12t minus h equals 0. All right, ground below is given by the formula. All right, solve this formula for t. That's what they're saying to do. Solve this formula for t. All right, so what we need here is the quadratic formula. This h here kind of messes us up a little bit. We don't know what the height is. Okay, so when it hits the ground, well, actually we do. All right, but I'm going to get back to you on that one, because right now they're just saying to solve this formula for t. All right, so let's see. If we use the quadratic formula, I know it's going to be negative 12, that's negative b, plus or minus the square root of b squared, which is 144, minus 4 times a, which is 16, times c, and c is negative h. And that kind of throws us off a little bit, right, with that negative h. All over 2a, which is 32. 2 times a is 16, 2 times a. All right, so that's it for what we've got. And now let's work on the radical here. So let's see, starting with the beginning, I got positive 12 plus or minus, and let's see, what is this here? I've got 144, negative 4 times negative h is 4h. Okay, so that would be 4h times 16. Well, that's going to give us positive 64h. It looks like. All right, and that's going to be my radical. So it's going to be the square root of 144 plus 64h, all divided by 32. All right, so what we want to do here, which may be the part you forget, is we can factor out something in this between the 144 and the 64H. And that would mean that it would look like I'd have 12 plus or minus, and now in this radical here, I can factor out a 16. If I factor out a 16, I'm going to have 144 divided by 16 is 9. So I'll put back 9 plus, and 64H divided by 16 is going to be 4H. Okay, and that is all over 32. So far, so good. All right, now I've got the square root of 16, which is 4, so I can bring the 4 out. And I'll rewrite this again, 12 plus or minus. The square root of 16 is 4, so that comes out, and I'm left with the 9 plus 4H, all divided by 32. All right, and now we can simplify this a little bit here. I'm going to stick with what the book's doing. I'm going to factor out a 4 here between the 12 plus or minus 4. All right, and that's going to look like this. It's going to look like what? I'm going to take out a 4, and then I'm going to put back 12 divided by 4 is 3, plus or minus 4 divided by 4 is 1. I don't have to write anything, but I do have to put back the square root of 9 plus 4H. All right, does that make sense? I guess I can do it that way. Yes, and that's all over 32. Now I can simplify. 4 is a factor now, so 4 goes into 4 once, and 4 goes into 32 8 times. Okay, and what's left is going to be my answer. So my final answer will be 3 plus or minus the square root of 9 plus 4H all over 8. All right, so now I have a square root involved, so I got to check my solution. I don't have a solution though, do I? I just have an expression. But if we go back to the problem, and it's saying if an object is tossed into the air with an upward velocity of 12 feet per second from the top of a building h feet high, well, here's my diagram of that. The time it takes for the object to hit the ground below. The time it takes for this object to hit the ground here. What is the height of the object when it hits the ground? And looking at that carefully, the height would be 0. Because if I start here and I want to measure the height, if I start here, this is 0 and it's going to go up. 1 foot, 2 foot, 3 foot, 80 feet, whatever the number is, it doesn't matter. But when it hits the ground, the height of the ground is 0. All right, so that means I can go back to the equation here, and when I want to know how object hits the ground, well, the h is going to be 0. Okay, if I plug in 0 for h, I end up with 3 plus the square root of 9, which is 3. Oh, that's 3 plus or minus, by the way. Yep, over 8. So I'm going to have my 2 times here. So I'm going to have 3 plus 3 is 6 over 8, which is 3/4 of a second, and 3 minus 3 is 0 over 8. 3 plus 3, so as you can see, one of those answers doesn't make sense, that it takes 0 seconds for it to hit the ground, but the other, the 3/4, it does. All right, we answered for when an h hit the ground, so this is our answer. 6 over 8, you know, it simplifies to be 3 over 4. All right, so that's the first way. And you could see that it was kind of like tedious doing it that way. If I'm answering this problem, from the beginning. Okay, and here it is. If we notice that the h is there, then, well, if we want to know the time it takes for the object to hit the ground, again, focusing on this h, well, we could say at this point that h is 0 and solve for t. So if h is 0, that means this is gone. And then I've got 16t squared minus 12t equals 0. And then all I need to do is factor out the t. If I factor out a t, I've got a 4t here. 4t comes out, and what's left over is 4t minus 12 divided by 4 is 3. Okay, that equals 0. All right, so solving for t here, this t would equal 0, because 0 times 4 is 0, and it would wipe all this away, so I'd get 0 equals 0. And then if I have 4t minus 3, put that equal to 0, then when I solve this, I'll add 3 to both sides and divide by 4. So t would equal 3 over 4. I'm just solving for t here in this little binomial, so I hope that's okay with you. So t equals 3 over 4 is my second answer. And there they are. I had t equals 0 for this one, and t equals 3/4. Isn't that a lot easier? Yeah, it's just knowing ahead of time. And the more problems